Right, good afternoon, everyone. So this presentation is on standardised scores and scaled scores. So just to give you a bit of context and background, obviously, as you'll know, for the first time, 2016 was the first year in which the Key Stage 2 test scores were reported as scale scores rather than national curriculum levels. So in order to help schools better understand these test outcomes and put them in some sort of context of other assessment data, this presentation will consider the different methods of reporting test outcomes, and we'll compare scaled scores with other commonly reported test outcomes, such as standardised scores. So, just as an introduction, there are a number of different ways in which you can report the outcomes of a test. Classroom-based tests, typically the simplest way of reporting a score is obviously the raw score. That's the total test score that a child got. So, for example, 15 out of 20 on a maths test. The other common way of reporting it, of course, is the percentage correct. So 15 out of 20 would be 75% correct. So they're great because they're very simple things to understand. But unfortunately, if you just use a raw score or percentage correct, it does have some disadvantages. So, for example, it doesn't take into account how difficult the test is. So it's not possible to directly compare raw scores from different tests in a meaningful way. So, for example, if you got 18 out of 20 on an easy maths test and 16 out of 20 on a very difficult test, which is the better performance? You can't actually tell that just from a raw score. So as a result of these issues, some assessments use alternative metrics for reporting test outcomes. Some of the common ones are standardised scores, age-standardised scores, and scaled scores. And these overcome some of the issues with raw scores and percentage correct. So in this presentation, we'll briefly consider these different approaches, the advantages of using them, the similarities and the differences between scaled scores and standardised scores. So this next slide just illustrates that point that actually different tests report different things. So in the top left, you've got the Key Stage 2 National Curriculum Maths test, which is reported using a scaled score. In the middle, we have two NFER optional tests, which report using standardised scores and age-standardised scores. And on the right-hand side, we have a typical classroom-based test from which you'd only be able to report a raw score and a percentage correct. So coming on to the advantages then of standardised scores and why we might want to use a test which makes use of standardised scores. So firstly, it enables you to directly compare test takers with a national representative sample of test takers. So rather than just looking at pupils within your class, you can compare their performance to pupils across a wide variety of schools. Also, standardised test scores, they can be readily compared. So you can compare tests, performance on different tests on the same scale. This means that it's easy to compare results, say, for a pupil on a Year 5 maths test with those on a Year 5 reading test, as the scale is the same in which they're being used. So this can be really useful, and we'll give you an example of how you might be able to make use of that data later. Standardised scores are also a really useful benchmark of the performance of an individual, class or year against the national average for a test. So as they're trialled on lots of children, you can get a national average, so you can really see how your children are performing in relation to a national average. So that's good for benchmarking. So in standardised scores, so they're related to two different things. So firstly, the average score of all the test takers. So if you have a large sample, lots of, say, 1,000 children have taken the test, the average score of all the test takers is calculated. And the other thing that they take into account is how spread out the test scores are for the test takers. So typically you'll have a range of marks. There'll be more in the middle towards the average, but then obviously there'll be some very high performers and some low performers on the test as well. So the spread is a really key measure with standardised scores. And we'll show that visually on the next slide. This is as technical as the presentation gets, so don't worry if this bit seems a bit technical. But typically with a test, you get what's called a normal distribution. So if it's a large sample of pupils who have taken the test, you'll get this bell-shaped curve. And on the presentation, you can see in the middle as an X, that marks the average performance. So the mean, so that's set at 100 on a standardised score. So even though the test might not be out of 100, we set the average at 100. And most people will get towards the middle. So you can go 85 to 115, so that's what's called a standard deviation. So within one standard deviation of the mean, you see 68%. If you add the two 34% together, 68% of pupils will typically score between 85 and 115 on the test. And then if you go further apart, you see as you go further away from the mean, less pupils get those sort of scores. So within two standard deviations of the mean, that's between 70 and 130, you've got over 95% of the population of people taking the test score like that. So this is perhaps the most useful thing, is comparing standardised scores. So here we've got the output from a test. We've got 4 pupils, and what we can do is we can compare performance between subjects as well as within subjects. So you can compare the performance of the 4 pupils within reading, for example, but you can also compare, say, Brian's performance in reading and maths as well to see which one he's performing more strongly in. So if you look at this table, you can tell from this table that Amy has the strongest performance out of the 4 children in maths, as her standardised score is the highest at 116. If we take Helen as an example, we can compare her scores in reading and maths. So with a standardised score of 120 for reading, Helen's performance in reading is considered well above the average, as it's much higher than the standardised score of 100, which we set as the average. Later in the presentation, we'll consider confidence bands and determine how you can establish whether there are statistically significant differences between test scores. For example, between Brian and Helen's standardised scores on the maths test. So we can say, actually, is that difference a large difference, significant difference in their score or not? And looking at this, by contrast, with a standardised score of 100 on the maths test, you can see Helen's performance in maths is considered average, as her score corresponds to the average standardised score of 100. So her performance in reading is higher than in maths. A feature of the NFER tests, and some other commercial tests as well, is age standardisation. So in primary schools, older pupils in the year typically have slightly higher average raw scores than younger children. They're that bit more mature, that bit older. So age standardisation can take into account the difference in age between pupils in the same year group by comparing pupils with other pupils of the same age. And when we say same age, we usually mean in terms of years and months. So 8 years and 1 month old. If a child was 8 years and 1 month old, on an age standardised test, they would only be compared with other pupils with the same age. And this is useful to take into account of this factor as well, because this can have a reasonable difference at primary school on performance. So here we've got an age standardisation table. So this is the output from a year 3 reading test, and you can notice from this table, along the top we've got the age in years and months. So 8.01, for example, means that the child is 8 years and 1 month old. And if you notice that in this table, for the same raw score on the left-hand column, a younger pupil may actually get a higher age standardised score. So for example, an 8-year-old pupil with a raw score of 32 has a age standardised score of 101. And that's higher than a pupil aged 8 years and 3 months with the same raw score, which is a 32, which gives you an age standardised score of 99. And also, pupils with lower raw scores may have a higher age standardised score. So for example, an 8-year-old with a raw score of 30 has a higher age standardised score, that's 100, than a child aged 8 years and 3 months with a raw score of 32. Their age standardised score would only be 99. In both of those examples, though, the difference in the age standardised scores is only 1 or 2 points, so they're very small. So you can't really state there's a significant difference in performance between the children if their standardised scores only vary by 1 or 2 points. And we'll talk about how you can infer whether the difference is significant or not now. So a quick note about tests. As teachers, you'll know that tests kind of only a snapshot in time. They don't give you the complete picture necessarily. So a test cannot assess all aspects of the curriculum. So for example, the Key Stage 2 maths test, a national curriculum test, can't possibly test all aspects of the Key Stage 2 national curriculum. If it were to, then it would make for a very long test. Instead, the test only samples the curriculum or programme of study. It only samples some aspects of it. So if you gave the same child a different test assessing the same subject, say maths, with different questions, then it's likely that the child will get a slightly different score each time. And on the slide we say a true score, that's something we use in test development and assessment. It's a hypothetical perfect measurement. So if you could sample the whole curriculum, you had a test which could sample every aspect of the maths curriculum with no external influences, so the children weren't tired or distracted or losing focus, then you could get the true score for that child, say at Key Stage 2 maths. However, that's more of a hypothetical or theoretical thing. So with any test you take, any test that a child takes, there's always a margin of error in the standardised and age-standardised scores. So to take that into account, we can calculate what's called a confidence interval, which gives you a confidence band. And this shows you the extent of the margin of error in the standardised and age-standardised scores. So kind of putting it in a different way, the confidence bands show you how accurately the test measures the pupil's ability in the subject of interest, whether that be reading, grammar or maths, for example. And in tests used at primary school, typically you get 90% confidence bands. They're commonly calculated for tests such as the NFER tests to give you the standardised scores and age-standardised scores. What does that mean then? So a 90% confidence band means that you can, with 90% certainty, know that the child's true score lies within the confidence band. So the bigger the confidence band, the less reliable your measure is on the test. So the smaller the confidence band, the smaller the margin of error, in effect. We've got an example here then of how basically this is showing you how you can use these in your classroom, and tests like the NFER tests do provide this data for you to use. So we've got 3 pupils here, Paul, Emma and Sophie, and if you notice they all have different standardised scores on this reading test. So the right hand column shows the 90% confidence band. So for Paul, we know that with 90% certainty that his true score in this in reading is between 90 and 106. And we can see Emma's standardised score is slightly higher than Paul's at 102. However, we'd want to know actually whether 102 is a significantly higher score than 98. So the confidence band, so we work out the confidence band for Emma, and we can see that we know with 90% confidence that her score lies between 94 and 110. So you can see that with these two, the confidence bands overlap between the two for Paul and Emma. And there's no statistical difference between their scores. So they can both be described as having broadly average performance on the test, because both of the confidence bands cross the 100, so they go within the average. If we look at Sophie, however, we can be 90% certain that her true score in reading lies between 112 and 128. And we can see that the confidence band for Sophie does not overlap with either Paul or Emma. That means that we can say in statistical terms that Sophie has scored higher than Paul and Emma on this test. We can also say that her score is significantly above the national average, as the lower limit of her score, 112, is still above a 100. So we can say that her performance is significantly above the national average on the test. So this is a really useful thing, really useful feature of the NFER tests, is that you can actually make these sort of inferences, which simply wouldn't be possible using a test which just reports raw scores and percentage correct. Scaled scores then. So the outcomes of the Key Stage 1 and 2 national curriculum tests are now reported as scaled scores. And we get lots of questions about the differences and similarities between scaled scores and standardised scores. And whilst they do bear some similarities, they are different. So we'll briefly go into scaled scores now. So we've got a graphic here, and this is the national curriculum scale score for Key Stage 1 and 2. So what we have is 100. A score of 100 points on the scale is what a child should score if they've met the expected standard at the end of the key stage. And the scale has a range from 80 to 120. So the minimum scale score you can get in the SATS test is 80 and the highest 120. Here we've got an example of a pupil's output, scale score output from the Key Stage 2 tests from this summer. And you can see that this child, For grammar, punctuation, vocabulary and spelling, his score is 100, his scale score, which means he's working at the standard, the AS, at the expected standard. For reading and mathematics, you can see that his scale scores are 99 for both subjects. And there's an NS in the outcome. That means he's not met the expected standard. He's just below the expected standard for reading and maths at the end of Key Stage 2. You can also notice here that on the 3 tests, there are actually different numbers of marks for each of the tests. And that's quite important, and we'll come on to that in a second as to the significance of that. So you'll notice that for grammar, punctuation and spelling, it's out of 70. For reading, it's out of 50, and for maths, 110. So why do we use scaled scores? Why are scaled scores used in the national curriculum tests? So we've already said that different subjects there have different numbers of marks available. Also, the tests vary each year. The questions are different each year. So that means that actually the difficulty of the tests can vary slightly year on year. It's impossible to get the test exactly the same level of difficulty each year, although it's that they make every effort to make them as similar as possible in terms of difficulty. So converting from the raw score into the scaled score, that allows direct comparison of performance between the different years. So that means that we can be sure that a score of 100 this year, a scale score of 100 is equivalent to a scale score of 100 in 2 years' time. We've got a graphic to sort of illustrate that now. So the scale scores are statistically adjusted to account for any small differences in the difficulty of the tests in different years, the national curriculum tests. So in this example here, Test B, you can see, is easier than Test A. As a result, a higher raw score is needed on Test B than Test A to achieve the scale score of 100. So on Test B, a score of 73, a raw score, gets you a scale score of 100. But on Test A, you need, because it's a slightly more difficult test, you need a lower raw score will give you that scale score of 100. And we know that the expected standard is going to always be set at 100 on the scale scores, and the range that will be used is always going to be between 80 and 120. So that's why there's an advantage there that each year you'll be able to make inferences of your pupils, whether they're at the expected standard or not. And for national benchmarking, you know that the same scale score each year means the same thing. So the similarities then between standardised scores and scaled scores. So they both take into account variations in the difficulty of the assessments. That's why they're set onto a common scale. So that in standardised scores, you've got 100 as the standardised mean, and in the scaled scores, again, it's 100. And both allow direct comparison of performance between different assessments. So, for example, we can tell for that child earlier that they were at the expected standard in grammar, but not working at the standard for reading and maths. So it's allowing you to compare between different assessments. And also the raw score in both standardised and scaled scores, the raw score is the basis for calculating both the standardised score and the scaled score. And just a bit of a comparison, because quite often it's a bit confusing the way the tests, the NFER tests and the national curriculum tests from the Standards and Testing Agency. It is a bit confusing sometimes because the metrics are very similar. So just running through these then. So on a standardised test like the NFER ones, the average score is set at 100. So the average, the national average. With the STA tests, the expected standard is set at 100. And the expected standard is not the same as the national average. They are different. So the expected standard is what a child is expected to reach that level at the end of year 6. And it's not the national average. So for example, in 2016, the average scale score for the Key Stage 2 Maths SAT was 103. So you can see there that the national average is slightly higher than the expected standard, which is set at 100. On the NFER standardised scores, they range from 70 to 140, and that's typical across most standardised tests. Whereas the scale score range in the national curriculum test is slightly narrower. It goes from 80 to 120. So it's a narrow range of scores available. With standardised scores, they can take into account the age of pupils. So we mentioned earlier about age-standardised scores. With the STA scaled scores, however, they don't take into account, they don't adjust for differences in ages amongst the pupils. and both of the tests can be used for benchmarking at individual class or year group level. But for the standardised scores, you're benchmarking against the national average, but with the scaled scores, you're benchmarking against the expected standard. And then finally, looking at the selecting the most appropriate scoring output. So the selection of the most appropriate type of score output for a test will, so for example, how do you know whether to use a raw score, a standardised score, or scaled score? It's really going to depend on the purpose for which the assessment is used. And it will also depend on the way the test has been trialled and developed. And the differences between them mean that actually you can use these different types of assessment for different purposes. So a little bit then, just before we finish, looking at which score you'd report. So you always need to think about the aim of the assessment. What's the purpose? Why are you assessing the child? So if the aim of your assessment is to establish whether the child's met this unexpected or threshold standard, like the national curriculum tests, then the scaled score is the most appropriate output. If you're wanting to compare pupil performance between subjects, then you could either use a scaled score or standardised score. A raw score wouldn't be possible in this case because you wouldn't know the equivalent difficulty of the tests. If the assessment was just an informal check of pupils' knowledge or understanding, say of multiplication tables or spelling test, then a raw score would be a perfectly acceptable output. And then if you're benchmarking your school performance with national performance, then obviously you'll need a test which has been trialled and developed on a national scale rather than just in your school. So in that case, you'd need to use either a scaled score or a standardised score in order to make that level of inference from the test. So final slide then, just to finish. So standardised scores and scaled scores, they've got a number of advantages over raw scores. For example, you can, it makes direct comparisons more easy. Standardised scores and scaled scores are used in different types of assessment. For example, NFER tests use the standardised score and the national curriculum tests use scaled scores, and they have slightly different purposes. And finally, probably the most important thing, the actual reporting output you use on a test is going to depend on a number of factors. So firstly, what's the purpose of the assessment? Why are you doing it? And secondly, it will depend on the way the test has been trialled and developed. So to get standardised and scaled scores, you really need tests that have been trialled and developed on large-scale samples, whereas for raw scores, that might be something you've developed in-house in your school at a classroom level. So that concludes my talk, my presentation.
Great, thank you very much for that, Oliver. So we've got about 10 minutes set aside for questions, and just a reminder that if you've got any, you can type them via the question pane on the control panel on the right-hand side. It will only be myself and Oliver that are able to read the questions, and what I will do is read them out anonymously, so feel free to ask anything you like. We've actually had a couple coming in as the presentation has been going through anyway, and actually it looks like we've got a few more coming in, so we'll try and get through as many as possible. If we don't have time in the 10 minutes, then what we'll do is follow up with any unanswered questions with you directly after the presentation. Just to let you know as well that the slides will be sent to you after the presentation also, and we will also send a copy of the recording. So we've had a couple of questions through. So Oliver, we've been asked, what are the means to judge whether a test is harder one year over a previous year?
That's a really good question. So the way the tests are developed, the national curriculum tests, means that they're trialled. There's 2 large-scale trials of the questions. So there's a standardisation trial, which the questions are presented to a large sample of pupils, nationally representative, and then they're marked externally, and they can get the difficulty of the questions from that, so they work out how many people's got the question correctly and how well they discriminate and that sort of thing, and that's what they use then to build up the actual test. So they've got lots of data on each question before it goes into a live national curriculum test or a standardised test as well. So from that information you can infer how difficult the questions are, and also they do anchoring as well. So when they trial questions for next year's test, children will also be presented with older questions, so which we know what the performance has been. So there's a statistical anchoring approach used as well. I hope that helps.
Lovely, thank you. And then also, so do all tests offer age-standardised and standardised scores?
That's a good question. In terms of that, the answer to that is no. the reason why is in order to get an age standardised or a standardised score, you need to have trialled the questions on a large, or the test on a large sample of pupils, and some tests simply don't. The level of trialling and development means that that's not done. So the NFER tests do offer that, but lots of commercial tests don't, because they've only been trialled on a small scale, on a few pupils. So they can't actually calculate those figures from them.
Great. And then which is better to use, a test which reports a raw score or one which reports a standardised score?
Obviously, it would depend on the what you're using the test for. Both offer advantages. Obviously, a test with a raw score is simple to use, simple to understand, and you could maybe develop it within your school quite easily. But the standardised scores offer a number of advantages in terms of being able to make more comparisons with a national sample of pupils, or benchmarking, and that sort of thing. So really it will depend on the purpose to which you're using the test as to which approach you'd use and which sort of test you would use.
Great, thank you. I can see we've actually got quite a few questions coming through, which is really nice. I can see we've got a couple around measuring pupil progress between the autumn and summer test. It might be, there might be somebody better to answer that question actually. I don't know if you want to take that one on, Oliver. I can read it specifically. So it's how do you measure progress, i.e. age standardised score from autumn to summer is identical. For example, a child scores 99 on both. Does that mean no progress?
That's a really good question. Progress isn't linear, as we know. So obviously that means that, progress isn't linear, so just because you get the same standardised score, age standardised score, that doesn't mean that no progress has been made. Obviously, they've been taught more of the curriculum. They've been learning new things. So obviously, you can, if the scores stay the same, that doesn't necessarily mean no progress has been made. There are more ways to measure progress than just simply a test. Although on the face of it, it might look like no progress has been made. I mean, you'd be in a better place to make a more holistic judgment as to whether the child has made progress. And also, you need to bear in mind that actually there are margins of error on tests as well.
Great, thank you. I'm quite conscious of time and the amount of questions that we've had coming through actually, so I think if we draw it to a close, but just to make you aware, I can see all questions here. I can see a lot specifically around scaled scores and a couple around what NFER plan to do in the future. I know that we've actually got some information on this, so what we do is follow up any unanswered questions with you afterwards. We'll just drop you a quick email with a detailed answer to your question. A couple of people have asked as well, will we share the slides? I think, sorry, I probably covered that straight after you asked, but yes, we will share the slides with you. We'll also send a recording, so feel free to share that with any colleagues or anybody that may find this webinar useful. In front of you, you should be able to see the screen as well that just says, if you've got any further questions, Oliver has kindly shared his email address there, so feel free to bombard him with any questions. And if you've got questions specifically about our NFER tests, we've got a dedicated helpline as well. There's a number and an email address there, or you can find any information on our website as well. I think that's everything from us, but we will follow up. Just to let you know as well, we've got another webinar, Age-Related Expectations Outcomes, a tool for assessment, teaching and learning. That's on the 7th of December at 4 p.m. What we do in the follow-up email to this, I'll just send you a quick link just in case any of you would like to attend that. So I think that's everything from us. So thank you very much to Oliver for presenting, and thank you all for taking the time out of your day to join us. We hope that you found it really useful, and please do enjoy the rest of your day. Thank you.